All right, IB AI SL2, we have reached the end of our little baby calculus unit, of the first baby calculus unit. There's more to come. Today we're going to talk closure notes, everything that could pop up on the assessment for this. So, first thing we started talking about were tangents to curves. Remember, if you have a curve, that looks like this, that you can have a tangent at any point. Like if I pick this point right here, a tangent is a straight line that goes through just that point, and it's a y equals mx plus b that has a slope and it has a y-intercept. Another thing I should mention is that slope is the same thing as the word gradient. Gradient seems to come up a lot. It's just the same thing as slope. Sometimes you have to use your slope equation to find y2 minus y1 over x2 minus x1. Remember that any tangent curve also has a y-intercept, which you can solve by plugging a point in to solve for the y-intercept. The big thing we're doing in this unit is derivatives. Now, the way you find a derivative is with the power rule. The power rule is just taking that power and bringing it out in front and then dropping it down one. So here it is out in front, and then you drop it down one. Notation for derivatives. Sometimes we say f prime of x, sometimes we say dy dx, sometimes we say y prime. There's a lot of different ways to represent it. Derivatives are basically where there's a horizontal, let's add that. A derivative, well, no. So when f prime of x equal to 0, that means there is a horizontal tangent. So in between the horizontal tangents, functions are either increasing or decreasing. So if you can find these stationary points when f prime of x is equal to 0. So you set the derivative equal to 0 and solve, and you can find stationary points. This is places on the curve where there are sort of maximums and minimums, which comes up later here in a second. Yeah, that horizontal this is where the derivative is equal to 0. You can always figure out where functions are increasing or decreasing by doing a little zone test, by plugging in x values that are either outside or in between the stationary points, and figure out, if it's a positive derivative when you plug it in, that means it's going uphill. If you plug a number in and it's negative, that means it's going downhill. Be prepared to find equations of tangents and normals, so y equals mx plus b. Remember that a normal is completely perpendicular to a tangent, so you need to know how to find perpendicular slopes, where if the tangent slope is a over b, then the normal slope is negative b over a. Maximums and minimums. Local maxes and local mins are where the derivative is equal to 0. Remember, if the slope, like right around that point after you solve for 0, goes from negative to positive when you plug in the x values on either side into the derivative, that means that you have a minimum. So come down and then turn back up. So like here it's going downhill, that's negative. Here it's going uphill, that's positive. A maximum is the opposite, where it switches from positive to negative. So here it's going uphill, here it's going downhill. So maximum, minimum. The last thing we did is we talked about word problems. This seemed to involve a lot of geometry. There was usually like volume or surface area or, rectangular armadillo pens, what have you. The other time it didn't involve geometry, it seemed to involve like a lot of cost equations or profit equations that they just straight up gave you, and then you just had to take the derivative of them. Some calculator skills you guys need to have. Be prepared to graph the original equation and look at it. Sometimes that involves a little window adjust, so sometimes it can be annoying because you can't see the graph. From there, you should be able to use that calculate button to find the maximum and the minimum, which is kind of cheating because you don't have to use derivatives at all. Or you could just graph the derivative and then set it equal, use the 0 function to figure out where it crosses the x-axis. That's kind of the cheater way to solve any algebra equation. We did do a little bit with the solver function. in that last video, but instead of using the solver function, you could just go this route where you graph it, figure out where it's equal to 0. Those both work. They give you the same thing. Okay, you guys, happy studying. Come ask me questions. Good luck.